Hello everyone. I hope you're all doing well today. Today we are going to learn how to sketch the graphs of polynomial functions, and we're going to do this in just two simple steps. Our first step is going to be to make a table of values to find several points that lie on the function. When I make my table of values, I'm going to choose several values to substitute into my function for x so that I can get a point to graph in my second step. Here I'm going to choose to plug in the values of -3 through 3 into my function. So when I start off by plugging in -3, I'm going to substitute out every x with -3. Remember when you substitute a value into the function to put it inside parentheses. So I would have -3 to the fourth plus 4 times -3 to the third minus 4 times -3 squared. My first step in simplifying this is going to be to take care of all of my exponents. So I'd have p of -3 equals -81. -3 to the fourth is 81, multiplied by the negative out front is -81, plus -3 to the third is 27. 27 times 4 is 108, so I'd have plus -108. Minus 4 times -3 squared. -3 squared is 9 times 4 is 36. When I add together all of my values, I get that p of -3 is equal to -225, which gives me the point on my function of -3, -225. I would continue this process of plugging in the values and get the remaining points as well. I would get the point -2, -64, -1, -9, 0, 0, 1, -1, 2, 0, and 3, -9. We can also note at this point that we have two important points here, and they're important because they're intercepts. We have 0, 0, which is both an x and a y intercept, and 2, 0, which is another x-intercept. Please take a moment to pause this video and record down what we have done in the example thus far. After creating a table of values and finding several points that lie in our function, we now need to determine the end behavior and use both the points and the end behavior to sketch our graph. Looking at my function, my degree is 4, and my leading coefficient is -1. So I have an even degree function with a negative leading coefficient. Since it's even, I know both of my arrows would be pointing in the same direction. With a negative leading coefficient, they're both pointing down. So my end behavior in terms of symbols would be as x approaches -infinity, y also approaches -infinity. And as x approaches +infinity, my value of y approaches -infinity. At this point, we're going to graph our points. We may need to change our scale and not go by ones on our x-axis because we've got some rather large numbers. Instead of going by 1, I'm going to go by 10 on each of my y-axis. Now that I've labeled my axis, I'm going to go ahead and plot my points. I still can't fit all of them on here, but I should be able to fit enough to be able to create the general shape of the graph. If I go to -2, -64, that point would be right about here. -1, -9 would be approximately right here. 0, 0. Let's see, 1, -1. 2, 0, and 3, -9. Now, my end behavior said that my arrows are pointing down, so I can connect those points and go down, and connect the rest of my points and draw my arrows going down as well. At this point, we have sketched a rough graph of what this function looks like. Please take a moment to pause this video and finish recording the example. Also, please record any questions that you may have for when we get together at our next Zoom meeting. Have a great day.